In this lecture video, I would like to demonstrate some of the practical problems dealing with the sampling distribution of sample proportion, and in particular I would like to take a look at problems from our chapter, which is from section 8.2, and just to carry over from the lecture in the previous video, I would like to start with problem number 11, and I believe number 12 was assigned for you to work on, so hopefully number 11 will help you with that particular problem on how to deal with the sampling distribution, especially the description of the properties and the distribution behavior of the sample proportion to describe its binomial property when the population size is given to us. Okay, so let's start with that problem, and let me bring a new sheet so that we can start with. Now, in this particular problem, we are given that the sample size here, the problem says that a simple random sample of size n, so this is number 11, that a sample size n equals 75 is selected from a population whose size is 10,000. Okay, and with a population proportion of 80% or 0.8. And now part A, we are asked to describe the sampling distribution of the sample proportion. In other words, we want to describe the p-hat distribution. Remember that the p-hat from our textbook and from my lecture video and lecture note is called the point estimate, which is basically the number of observations divided by the sample size. Now, just a point in case here, you see, if the population proportion is given to us, this is particularly referring to the probability of success, meaning that it is the proportion of interest. So we can also find the probability of failure, which is the proportion that we are not interested in, which is the complement to the proportion that we are interested in. So basically what I'm trying to say here is that if we know P, we can find Q, because Q is basically 1 minus P. So in this case here you have 1 minus 0.8, which gives us 0.2. Okay. Now, in order to describe the sampling distribution of the sample proportion, we have to test the data to see whether it satisfies the binomial property and that it has what we call a normal distribution. To do that, there are a couple of conditions that we need to test, and I have provided you, actually there are 4 of them. And now the first one, you can see that by default, if the population size is given to us, then we have the condition, and the test condition we will use is as follows. So here is that we need to test that whether the sample size is actually at most 5% of the entire population size. So here we want to find out if 75 is actually less than or equal to 5% of the population size. So here we have 0.05, multiplied by 10,000, and obviously that will give us 500. So apparently the data satisfies the binomial property and that it is approximately normal. Now you see here, the whole idea to test this data is to make sure that it has this property. So when this condition is met, what that means is that if we were to construct a histogram or to construct a distribution curve, then the data will produce or would produce a distribution that looks like this, which is a bell-shaped curve. And the bell-shaped curve is what we mean by a normal distribution. That's what that means. Okay, and when we have a normal distribution, we can convert it to the standard normal. That's the whole idea of finding out whether the distribution is normal based on the data that is given to us. Okay, so this condition is satisfied, and therefore data possesses the binomial property, which it has the normal distribution, and therefore we can now describe the property or properties of the distribution of the p-hat. And the properties are as follows. So I guess I'm going to squeeze it. You know what I'm going to do here is I'm going to reclaim my room by basically going backwards, because you already saw what we were talking about. So here the properties are the following. We have that the mean of the sample proportion, will be equal to the true population proportion, and that is 0.8. Okay, that much is clear, you know, because that information is given to us in the problem. Then the second property is the standard deviation of the sample proportion, and it's written as sigma of p-hat, which is basically the square root of p times q over n. In this case, we have a square root of 0.8 multiplied by 0.2, and 0.2, the reason that I have outlined earlier over here, and then divided by 75. And so let's see if I can remember where I had. Okay, it is my calculator. I was looking for it. So here is the result of that. So we have basically a square root of 0.8 times 0.2 and divided by 75. The whole thing square root under the radical, and that gives us a 0.0462 or 0.046. So here we have 0.046. Okay, and this is pretty much the description of the distribution of the sample proportion, and that answers question A. Okay, now what about B? Well, B actually asks us to, what is the probability of obtaining X, which is the number of observation, equals to 63 or more individual with a characteristic, and that is, what is the probability of p-hat greater than or equals to 0.84. So here this is basically two questions of the same thing. Okay, now let me outline the first question, and that it is basically one and the same with the second equation, or second question to be exact. So let's start with that. So the first question asks us, what is the probability of obtaining X equals 63 or more? Okay, let's just put it short like that. So here, probability of x equals 63 or more. Well, what that means is that we want to find out what is the point estimate of that. And the point estimate is actually x over n. In this case here you have 63 over 75. And let's do a quick calculation of that. So 63 over 75, that gives us 0.84. Okay, and that is pretty much the second question right here. See, that is, what is the probability of p hat is at least 8.4. So then we have this here, which is 0.84. So here we have 0.84, and thus the probability of obtaining p hat at least 0.84. And this is what we want to find out. We want to compute that. And to do that, we need to convert this. We already know from part A that the distribution of the sample proportion has a normal behavior, and therefore we can convert this. Okay, I'm going to say must convert to the standard normal curve. Okay, and to do that we need to apply the z-score equation, which is p hat minus mu of p hat divided by sigma of p hat, and the p hat is 0.84, which is from the actual expression of the problem, of the question to be exact, right here. And mu of p hat, remember from part A, which is this one right here. So mu of p hat is actually p, so that's 0.8. Okay, so we have 0.84 minus 0.8, all divided by 0.046. We can round this out to 3 significant figures. You know, we could probably carry to one more significant figure to the 4th place, but this should be enough. This should be good enough. Yeah. And so what we have then is I don't know. Let's find that out. So here we have 0.84 minus 0.8 divided by 0.046, and that gives us 0.87. We need to only extract 2 significant figures because that is the z value, right? And look at here, you see, that's why I have this table right here too. So the z value has only 2 significant figures. For example, let's take a look at this one right here. That's a negative 3.4, but over here is going to be a negative 0.340, a negative 0.341, and so on. So only 2 significant figures. That's what we need to keep. So I'm going to go back to that, and then this is what we have. So we got a 0.8. I forgot what that was. Let's go back here. So probably this is quickest way that way. So here it's 0.87. Okay, 0.87. Thus, we now are able to write, I'm going to just say over here, let's start like that. The probability of p hat, which is 0.84, is now based on the standard normal curve, is z greater than or equal to 0.87. Okay, so this is the curve that describes that. So this is a 1, a 2, and a 3. A 0.87 is somewhere around here, close to 0.9, and it is greater than that value. It's to the right of that value, to the right of that line. And you see here, by using symmetry argument, we can use a mirror image of the figure, that it is now basically a negative 0.87, so that I can rewrite my probability expression and then apply the z-table that is in the book. So now it becomes a z less than or equal to a negative 0.87. In other words, we are looking for the area to the left of the negative 0.87, and that one our table has, which is this one right here. Okay, so 0.87 right here. I believe the last column here is 0.9. This is 0.09. This is 0.08, and this is 0.07. So basically, it's the third column from the right, and now it's a negative 0.87. Right where my arrow is pointing at is 0.1922. That is the answer. Okay, 0.1922, and that is the answer. Now I will provide the interpretation of this result in the next example, the next part of this problem. Let's move on with part C. Okay, right here, part C. So part C is asking us, what is the probability of obtaining x equals 51 or fewer? Meaning that what is the probability that p is less than or equals to 68%, or 0.68? Okay, and I hope that my previous explanation of this was clear enough already. So let's just start with the actual probability expression. Okay, and we can start. Let me compute this for us one more time, just to be clear on this. So here we have 51 over 75, and that is 68. So here we have 68, and the probability that we are interested in is less than or equal to 0.68. And this is it's a perfect example that now we are computing or interested in an area to the left of a value which our z-table directly provides. So what we need to do now is compute the z value. So here we need to convert this general expression of the distribution to the standard normal distribution so that we can use the z-table. And to do that, we have the p hat minus the mu of p hat divided by sigma of p hat, and that is equal to 0.68 minus 0.8 divided by 0.046, and I don't know what that is, but let's find out. So here we have 0.68 minus 0.8 divided by 0.046, and that gives us a negative 2.1 or 0.61, negative 2.61, negative 2.61, and I'm going to say thus. So here the probability of p with p hat less than or equals to 0.68 in the z expression is z less than or equal to negative 2.61, and you can see here the curve looks like this. It's a negative 1, a negative 2, a negative 3, a negative 2.6 is somewhere around here, and this is the curve that we're interested in. So it's a very, very small region, you know, in the small percentage. And based on our z-table, you can see that the answer should be apparent to us that it's very extremely small. So here a negative 2.61. This is the first column. Here is a 0. The second column is a 1. Is a 0.01 to be exact. So here you have a negative 2.61, which is 0.0045. That is the answer. Very, very small, less than 0.5%. 0.0045. Okay. All right. And that pretty much concludes the problem from number 11, and I'm going to move on to problem number 17, which is my next discussion here, because I think you were assigned to work on number 12, so 11 will help you with that, and then you were asked to work on 16 and then on 18. 18 is a good problem, so I'm going to choose number 17 for us to work on this as an example to help you work with the homework assignment. Okay, and before we move on with that, I'm going to give us the video code. So the video code for this particular lecture video is 0.1922. That is the video code right here. 0.1922 is a video code. Okay, and so let's start with a new sheet. In fact, I need to get rid of this too, and maybe this one as well. Okay. All right, number 17. So number 17. So 17, it gives us the following. According to a study done by the Pew Research Center, 39% of adult Americans believe that marriage is now obsolete. I guess this problem is quite a controversial one, but for the sake of our argument and the practical problem of the sampling distribution of the sample proportion, we'll take a look at this particular and interesting problem. So here the information given to us that the proportion is 0.39. Okay, that's the only thing given to us. Then question A, it asks us, suppose a random sample of 500 adult Americans is asked whether marriage is obsolete. Describe the sampling distribution of the sample proportion. And basically the proportion of adult Americans who believe that marriage is now obsolete. So basically part A, we are told that the sample size is 500. Well, remember in the previous problem that in order to describe the sampling distribution of the sample proportion, we must test the data to see if it satisfies the binomial property and at the same time has a normal distribution. And to do that, you see in this particular problem, we do not know the population size. Therefore, the first test condition is not applicable in this case. So we're going to move to the next test condition. The next test condition from the list that I gave you in my lecture note or in my lecture video is the following: that n times p times q is at least 10. Okay, and in this case here we have, of course, again let me go back here, that if we are given p, we already know q, right? And just the complement of the p, in this case here, is 1 minus 0.39, which gives us 0.61. Okay, so we now have q and p. So here we have a sample size which is 500, and the p is 0.39, the q is 0.61, and we want to see if the product of these three numbers is at least 10. And again, let's get some help from a calculator. And we have 500 times 0.39 times 0.61. And the answer is 119. Okay, 119. That is pretty good. So we know that the data has a normal distribution and that it indeed satisfies the binomial property. So here you have 119, which is much greater than 10. Now, suppose, for example, let's say that if the product of these three quantities fails to satisfy this condition, you can also go move to the next test condition, which is n times p is at least 5, and at the same time n times q is also at least 5. So for example, like say, this one here, if it fails, you can also try another test to see. This is what we call a minimum testing for the binomial property. And of course these two, they have to be at the same time satisfied, and but in this case you can see here that the first condition is already satisfied, therefore there is no need to check this one. But if this one fails and we want to find out if the data actually has a minimum requirement or meets the minimum requirement, I meant to say, then this is the condition which I gave you also. Now the book did not quite talk about it, but remember that there are actually at least 4 different ways to test for the binomial property of the sample proportion. Okay, now that this condition is satisfied, then we can describe the property of the sampling distribution of the sample proportion, and those are that the mean of the sample proportion is actually equal to the actual population proportion, and that the standard deviation of the sample proportion is actually equal to the square root of p times q over n. In this case here you have a 0.39 for the mu of p hat, and then for the sigma of p hat you have a square root of a 0.39 times 0.61 all over 500. And that will give us, let me see here, so we have a square root of 0.39 times 0.61 divided by 500. Okay, so we have a 0.0218. Now I'm going to carry, like I mentioned earlier, this time we're going to practice this, and that is to carry our standard deviation, because it is in pure rational numbers. So we're going to carry it to 4 significant figures. So here we are going to report a 0.0218. That's what I want to report. Okay. So here we have a point. You see, in fact, the more significant figures you carry, the closer, the more accurate you obtain to the approximation. So that's why I want to maintain it as much as possible. So here we have a 0.0218. That is the standard deviation of the sample proportion, and that pretty much answers part A, to describe the properties of the sampling distribution of the sample proportion, which is the sample mean of the sample proportion and then its standard deviation. Okay, so that answers question A. What about B? B, what is the probability that in a random sample of 500 adults, less than 38% believe that marriage is obsolete? So here, let me start a new sheet. Here we are actually computing, so we want to find out the probability. So let me write it this way in one expression. We want to find out the to be less than right here. Oh, I did it wrong. Hold on one second. Let me go back here. To be less than to be less than x over n. Okay, so in this case you have p of p hat less than a right here, less than 38%. Okay, you know what, I'll just get rid of this here. It's to get it out of the way. So here we have basically 0.38. The point estimate right here is actually 0.38. Okay, now again, since we already confirmed that the data satisfies the binomial property and that it has a normal distribution, we can now convert this to the standard normal, right, which is the z-score. So here you have a p hat minus mu of p hat divided by sigma of p hat. So here we have a 0.38 minus 0.39 divided by 0.0218. Okay, so let's do a quick computation of that. So here we have a point, I got there. So we have 0.38 minus 0.39 divided by 0.0218, and that gives us a negative 0.45787, or we can round that off to two significant figures, because based on the z value right here we only have two significant figures. So we're gonna use a negative 0.46. That would be our answer for the z, right? So here is a negative 0.46, and hence now we can write that the proportion less than 0.38 can be written in the z as follows. And here this curve looks pretty much like this. So this is a -1, a -2, a -3. So a -0.5, which is a -0.46, is somewhere around here. And this is the region that we're interested in, which is quite straightforward because the z table in the book pretty much provides us that number. Okay, so let's look up the table and we'll get a negative 0.46. Well, the first one here is 0.40, 0.41, 0.42, 0.43, 0.45, 0.46. No, 0.44, 0.45, I miscount myself, and then 0.46 right here. So this is a negative 0.46, which is 0.3228. That is the answer, 0.3228 right here. Okay, 0.3228. Next question, and that should complete that part. Now I'm going to skip it and turn on a new sheet. So the next question is, what is the probability between 40 and 45% that adult Americans believe that marriage is obsolete? So here we are interested in computing the following. Okay, so let me just write that down right away. We want to compute the probability of 0.4 and 0.45. Okay, so here we have these two values. That's p hat 1, this is p hat 2, and this corresponds to a z1, and that corresponds to a z2. So we need to calculate that. So z1 is actually p hat 1 minus mu of p hat over sigma of p hat, and that is actually 0.4 minus 0.39 divided by 0.028, and then Z2 is actually P2 minus mu of P hat over sigma of P hat, which is 0.45 minus 0.39 all over 0.0218, and that gives us, I think here, let me bring my calculator here, because using that calculator is just too slow for us. So I'm gonna calculate that for you right away. So here I got a 0.4 minus 0.39 divided by a 0.0128, and that gives us a, oh, in fact that's the same one as the other one, which I should have remembered this, but since I erased the sheet already. So this is a plus 0.46. Okay, now the other one, the second one, is 0.45 minus 0.39 divided by 0.0218, and that gives us a 2.75. so this one here is a 2.75. now I'm going to rewrite this in, you see here, maybe I could probably squeeze it in here. So here we have P of Z now is between a 0.46. In fact, this is what the new expression in the Z looks like. Okay. And if you're interested in this, you can see here the curve looks like this. In fact, I recommend that you do this to check your answer. So here we got a 1, 2, 3, a 275 somewhere around here, and then a 0.46, which is a 0.5, is somewhere around here. This is the region that we are computing. Okay, remember in the middle is 0, a 0.46 is right here, and a 2.75 is right here. And we can split this. We can use the difference, split the first one, read everything from negative infinity, that means from negative infinity right here all the way to 2.75. So we read almost the entire curve like that, from negative infinity to a 2.75, and then minus the curve from negative infinity to 0.46, somewhere around here. The difference between these two will give you this little region right here. So the first curve gives us the probability expression like this: Z less than equals to 275. The second probability is Z less than 0.46 or equal to 0.46. So let's read the first one, 275. 275 is, I need a positive value, which is down here. So 2.75 in the sixth column, 1, 2, 3, 4, 5, 6. Sixth column is right here. Okay, so 2.75 is actually 0.99. So here we have 0.9970. That's the first one where my arrow is pointing at. So let's go back to here. Let's compute that. 0.9972. Now let's compute this one, or determine this one. And that one is a 0.46. So 0.46 is somewhere around here. Let's go up a little bit. 0.46, and the 6 is going to be the seventh column, right? So 0.0, 0.1, 0.01, 0.02, 0.03, 0.04, 0.5, 0.6. So here, right here, 0.6772 is the 0.46 right here. So 0.6772. The difference between these two values will give us the answer, 0.6772. And I guess I kind of ran out of room here. Let me see here. I guess I did. Well, let's just I'm going to use the right arrow like this. Okay, so that the answer is, let me do this quickly. So, oh, in fact, we could just subtract it right on the spot. So you have a 0.3, right? The first one is 0.3, the second one is 0.2, and then 0, 0. Okay. In fact, I think. Oh wait, no. I think this is. What did I think I wrote this wrong. This is not. Yeah, I think I did this wrong here. This is not. I wrote it too fast. This is not a 2. That is 0, right? Okay. Let's double check that. I believe it is a 2.75. Yes, it is a 0 right here. The 75. So 1, 2, 3, 4, 5, 6. That's the 6th column. So 0.9970, which is the right one. And so this is wrong then. So this should be a 1. Okay, that should be a 1. And then this one here will give us a 9. In other words, the whole answer is this. Subtract these two right here. So 0.3198. There, that's the right answer. Okay. So the interpretation of this could be that you can see that if, for example, let's say if we select 100 samples from this population with sample size equals 100, then we know that 32 of them, or 30% of the 100 samples, will be between the people in, the people that that believe, the proportion of the people who believe that 40% and 45% between that region believe that marriage is obsolete, is about 31.98% or 32%. In other words, we can basically multiply this by 100 to say that out of the 100 samples, 32 of them who believe that marriage is obsolete, and that is between 40% and 45% for those people. Okay, so that is the interpretation of that. And I think the last problem is quite straightforward too. It just pretty much asks, would it be unusual for a random sample of 500 adult Americans to result in 210 or more that believe that marriage is obsolete? Well, let's figure that out. Okay, so we want to find out if it is unusual. We want to see if it is unusual. We don't know yet. And you see here an unusual event, if you recall from chapter 5. Now remember, everything we learn in statistics is built on, so we still have to use knowledge from what we learned previously. So here, an unusual event is any event that is 5% or less, and that was described in chapter 5 in my lecture video and my lecture note. So let's take a look at this problem here. Part D. Part D, we want to find out the probability of P hat, okay, is at least greater than 210 over 500. We want to find out if that is unusual. And to do that, we'll take, I'm going to use my calculator again, it's quicker this way. So here we have a 210 divided by 500. That gives us 42%. So here you have the probability of P hat is at least 42% or 0.42, and that we need to convert now to the standard normal curve by using this expression. Okay, so here we have a 0.42 minus 0.39 divided by 0.0218. And again, I'm going to use my calculator. It's quicker that way. 0.42 minus 0.39 divided by 0.0128, and that gives us a 1.3761467889. And we can carry this to two significant figures, so it will be a 1.38 here. If you like to hear it one more time, it's like this, and so on. So I'm going to round it off, right? And now we are going to, and you can see this is quite straightforward again with a single number. So this is written as z greater than a 1.38, and the curve looks like this. So 1.38 is somewhere around here, and this is the region that we're interested in. And if you use a mirror image, it looks like this instead, you know, the symmetry argument. And this 1.38 now becomes a negative 1.38. And you see here, this is the region that is to the right of this value, and this region now is to the left of this value. So the expression in the probability is like this. And to look up the table, we'll have a negative 1.38 right here, negative 1.38. So 8 is got to be the second to the last column. So it has negative 1.38, which is right here, which is 0.0838. That is the answer. 0.0838. 0.0838. And this is pretty much this is pretty much 8%, right? 8.38%. And as I mentioned earlier, if it is 5 or less, if it is 5% or less, then that becomes an unusual event. In this case, the answer is that no. No, it is not unusual. Okay, to find that 42% of people believe that marriage is obsolete. That is the interpretation. So no, it is not unusual. And that concludes my presentation of these two examples, and that I hope that they will help you work on the homework assignment and again prepare you for the next exam. Thank you.